Hello there, rock stars. This is Michael Anthony, and this is Anthony Michael on the first ever episode of On the Rocks with harder rocks and even harder questions. Today, we are going to be sipping on some the finest of whiskeys, whiskies. What do we have today, Mr. Anthony Michael?
This is a bourbon, I.W. Harper 15-year, which should be interesting.
Excellent. Well, why don't we just go ahead and help ourselves to some, of course, whiskey stones.
Good things come in threes.
Good things do come in threes. How many would you like, sir? Three?
I think this sounds good.
Three sounds good.
And let's go for 2 ounces sound good?
2 ounces sounds fantastic.
We'll be here a while. I got a lot of questions.
We'll be here for a bit. Today, rock stars, we are going to be talking all about clay. That is right, the mighty mineral. It's not really a mineral, but it's it's a rock. We'll get into that. We'll get into exactly what is clay, where does it come from, why do we do stuff with it, and how deeply intertwined it is to being human and what humans are and what we do, and also the future of humanity as well, and some cool stuff there. It's all about clay, believe it or not, all here on the Rocks. So stay tuned! Delicious.
So I took, for the first time at a community center, a pottery class, because I've always been interested in that. And I thought it was just absolutely fascinating because, clay was just this random stuff that had so many interesting properties. And it seemed like this esoteric kind of thing in general before. And then actually working with my hands in it, I started to realize it had all these properties I knew absolutely nothing about. So just when it comes down to it, what is it?
What is clay?
Is it just dirt? Is it really good dirt?
It's the best dirt. It's a very specific kind. No, clay is actually exists on a scale reference for measuring the size of sedimentary particles, how big grain sizes are in sediments. So you have sands. You can imagine what a sand grain looks like.
Yeah.
There is a specific size range that sand can exist in.
Okay.
And that exists. And I actually have a little cheat sheet I used to use in my old job. So this, if you are a geologist, if you're studying geology in school, you might use a little ruler like this.
Oh.
You might get a nice little...
And that's like actually to scale. You can compare
that
to
to
things
close up. Yeah, and they have right here all of these little distinctions. It doesn't go. This is just talking about sizes of sand. So this is just sand grains. We got coarse sand, 0.2 to 1 millimeters. Coarse sand, 1 to 0.5 mils.
Yeah.
Medium sand, and it goes down and down. Very fine sand, 0.125 to 0.062 millimeters in size.
Okay.
And so that's just like a nice little handy little cheat sheet that you can just take with you and just have in your pocket and literally lay it on a rock and say, how big what are you looking at here, until you kind of get a feel for the size of things. Now, in terms of sizing comparative to our sand, clay exists at 2 micrometers. Micrometers, yes. And so our sand, our very fine sand is at 0.062 millimeters. And clay exists at 0.002. That is the size of a grain of clay. It is so unbelievably small, it is, by definition, naked to the human eye. You can't, see a clay grain, which is why, for a lot of people, clay is kind of an interesting rock when you consider it as a sedimentary rock, which is what it is. It's made up of tiny microscopic grains, as small as they can can get in some cases. Yeah. Really, really tiny. There's also a definition of clay based off of the specific mineral makeup of that clay that kind of distributes it, according to geologists, into different kinds of clays just based off of the metals that are attached to our clay particles, to our clay grains.
While all clay has that really, really naked to the human eye size going on, different kind of actual compositions can give you different kinds of clay that maybe has different properties.
And some interesting properties as well, as you kind of vary through that size range there. Smaller than 0.002 millimeters, there's a lot of room. There's a lot of room for nuance and difference between those grains. To be honest, I don't really know all of it myself. There's an entire field of study just dedicated to clays in more than one way, which we will actually hopefully get into a little bit later.
Oh, cool.
I hope I don't have to cut that part out. I don't know. Tens of angstroms, 2 millimeters in size. So is it? And so an angstrom is a unit of measure at the scale of atoms. So that's how small they can go. They can go tens of atoms up to millimeters in size. That kind of blew my mind as well. I think I found a sweet little SEM shot of some clay, little plates I'll put up on screen because it's sweet. Of just an electron microscope looking at these things. Now, what is really, really important with clay, aside from it being really, really small, is the water part of that equation.
And that's what blew my mind in the class, is like if I left my clay out too long, it got too dry to work with, and then I poured a quarter cup of water in the bag, sealed it up, came back to it next week, and it was
boom,
perfect consistency.
Almost brand new.
Yeah.
Almost, and that's really what's so cool about it, is you can keep working it and reworking it. It will get dry and cracked unless you're using what you might be familiar with, a polymer clay, like, or you're modeling clay, the kind of stuff that you don't really need to apply water to. It'll just, you can knead it, which we'll get into hopefully later, is not actually a out of the ground clay. Out of the ground, straight geologic clay is going to need water to stay in that hydrous, malleable state. You can use it and you can knead it and shape it into different shapes. Or without the water, it dries and it cracks and it just turns to essentially dust. It's going to be a very fine dust after it just kind of crumbles and falls apart.
Oh, at that point, with particle size that small, it's not something you want to breathe.
Not really, no. Yeah, so keep your clay wet, everybody. Cheers. Cheers to that.
Cheers to wet clay.
Cheers to wet clay.
So, with clay being defined a lot by, well, yes, mineral content, but also by particle size, if you're going to go looking for clay that you want to refine and use for different purposes, it's not as simple as just finding some sedimentary rocks, grinding them up real small, adding some water, and you got clay, is it?
That's a great question. I'm not sure about home making your own clay, but I know that, of course,
when you're getting down to the nanometer size.
When you're getting to nanometer size,
Micrometer, was it?
The best filter is always going to be Mother Nature. You can always trust Mother Nature is going to collect these things together for us, and that is primarily where you're going to find clay deposits are going to be these areas of extremely low energy, what they're called in sedimentary geology. Low energy environments are going to be mostly water driven, but very slowly so. So high energy environment, for example, or rushing rapids or crashing waves, it's high energy. That's going to blow away all except the mightiest and heaviest rocks, A medium energy environment is going to be kind of a little lower, where you have slightly smaller sized sediments that tend to kind of be deposited at that point. The lowest energy environments are so unbelievably slow, they are only going to be barely pushing along these micrometer thin little sheets of clay around, just even barely. And so by the time water gets that slow, all of our clay is just going to collect in these layers and these depositions here, just naturally by natural processes, because it's going to be too fast to deposit in the fast part of the river and the medium part of the river. So only the very slowest part, where it finally ends up in a lake, and the lake has completely stopped moving, essentially. Then all of our particles in the clay fall out of suspension, slowly sink to the bottom, and are essentially going to be ooze. It's going to be an oozy, mucky, very fine mud.
That's the only way they'll actually separate by particle size to that kind of specific.
That's how you can get that specific, that level of accuracy. Yes.
That's really cool.
It's great. I think lakes and very slow deltaic environments are the two main areas where you're going to find clay.
Okay.
Extremely, extremely fine mud, and it is also rock stars where you can get extremely fine fossils as well. Some of the actually best preserved fossils ever found in some cases. The feathered dinosaurs. Ooh, I have a book. The feathered dinosaurs found in the Jehol biota in China, the Liaoning province, where these dinosaurs, it's amazing. Some of the most well-preserved fossils that blew the cover off of the mystery of dinosaurs being related to birds, because of how fine-grained these clay particles were. preserved the feathers for the first time.
Oh my god.
The first time ever.
This is also a gorgeous book.
It's amazing, and it does not belong to me. I'm borrowing it for the time being. I need to return it, but it is a very, very good reference point for this video, actually. And the whole reason for the fineness of those grains actually wasn't due to sorting, due to water or rivers. It was volcanic activity. What's called bentonite clay. And actually, bentonite clay is interesting and used for all kinds of uses today, which is very cool. But it makes some of the best fossils, which is great. Things like these fish right here can be preserved in clay. Oh. Tiny little fish. You can see the details down to their tiny little bones and everything.
You actually can.
It's amazing for a paleo nerd like myself and a geology nerd. Clay provides some of the highest resolution fossils, as you can imagine, because the grain sizes are so small.
It gets in all those nooks and crannies.
It's in all the nooks and crannies, and as long as the conditions are just right, you can preserve something for a very, very long time. Oh, so cool. Oh my God.
I had no idea it had even just that uses in historical value. I mean, I saw that occasionally, even as far as humans being of the written word, so to speak, clay was one of the first things that people actually wrote in.
Really?
Which fascinated me.
Wrote on?
Yeah. Well,
that is amazing.
For
I
clay
didn't know
tablets and that kind of stuff.
That is fantastic. And
cool.
the archaeological perspective on clay goes back as far back as you said, human writing itself, but some people believe as far back as humans as a species, or even before that, perhaps. I don't know. Mesopotamians, Egyptians, pottery is so universal across so many cultures. It's amazing. It's amazing. I think I remember reading a very long time ago that the first pottery was probably on accidentally burned bottoms of fire pits that were built on top of clay beds. And after the fire, native peoples would have this basin essentially that was burned from the fire. Which is really crazy to think how far we've come since then.
You mentioned bentonite clay earlier, and I've heard that in terms of some wonky health stuff. Is that a thing?
Yes, that is a thing. It has been a thing for a very long time, where bentonite serves essentially as an antacid, from what I've heard.
Really?
Among many other claims. It's good for upset stomach, good for all kinds of things, good for, mud masks are going to be made with that fine clay, that fine bentonite in a lot of cases. Used in a lot of different ways. And if you have the right kind of clay, rock stars, ladies and gentlemen out there, it's chewable. You can chew on it, actually. And that's kind of a big way you can tell the difference between a siltstone and a clay stone is you take it and you kind of put it in your mouth, and the clay is going to be smooth. It's not going to have a gritty consistency at all, and the silt is going to be kind of gritty. You can kind of feel it on your teeth.
Silt has larger particles?
It's just large enough, yes, where you can kind of feel it in your mouth. But a clay is going to be very smooth.
That's good to know.
Yeah, so in case you didn't know, that's a little tidbit there for you. Yeah. But yeah, no, clay has been so huge for human development over time. We're talking like the development of culture through pottery. You're talking like a huge part of Greek culture was the art aspect of their pottery itself, and how big that was, and how really well known that is for Greek culture. And it's really wild to think how far back that history goes, and also how far we've come with it as well, in terms of our understanding of modern pottery processes. You were talking about your class, where you were, you make your pottery item and then you put it in the kiln to burn. That is a very precise process that, if not done correctly with the right steps and the right timing, can end up in a completely disastrous product. You can blow up pottery if you don't do it right. It'll just explode.
We were warned about that.
Yeah.
Because that has to get up to such crazy heats that if there's just pockets of water or air in there, it'll expand inside the layers of the pottery and just
pop your pottery. Just totally pop it. My goodness. Did they explain anything about the chemical processes happening in the annealing when you burn your pottery?
Not really, specifically. The most we got that I thought was absolutely really interesting is that the glazes itself was actually kind of like a silica compound with other elements to color it. So it was basically the glaze on the pottery was just this liquid solution of essentially glass that then you
Liquid
melt
quartz
onto the
glass. That is so cool. That is
really cool.
so wild.
But as far as the hardening of clay, like after you fire it, it loses the property where you can like grind it down, add more water, and work it again, right?
It does. It loses that property, and I did not know that until research for this video actually as to what exactly is going on.
What is going on?
It's wild. You are actually melting down the individual grains of clay, and they actually end up merging together. So the first step actually is removing all of the water. And in some cases, they might do a low temperature bake before they do a high temperature bake, just to let off all the excess water in there. And so you are releasing the water from that, and you essentially have just a bunch of tightly packed grains together. As they increase the temperature, essentially an oversimplification of what's going on is that these grains start to fuse together, meld together, until you get just your solid pot or item.
Oh, that's so cool.
And so it's no longer usable again because the grains have fused. They're no longer clay at that point. It is something entirely different after it's been fired, which is so cool.
So many of those little particles that are so small already probably explain some of the other like crazy unique properties that fired clay has. How great of a heat insulator it is. Like,
oh man, heat insulator. It holds water, of course, and just that's so wild. So wild. We've been doing it for so long too. You know, mankind has essentially existed side by side with this product from the earth.
I mean, when you think about human culture, growing food and getting food defined the early existence of mankind, right? So being able to transport water to grow crops not right next to a river, I mean, it makes sense. That's so cool.
That's huge. That's huge. It's quite a concept, quite a technology for early humans.
That is very much in certain ways still kind of unchanged, which blows my mind.
Still unchanged. That's right. It's like a lot of the cutting edge in a lot of different areas of application can be attributed to clay products. Not necessarily clay as we know it, but maybe as it is more formally referred to as ceramics. Ceramics is kind of your high grade scientific applications for what can be considered clay, because it is a little different. Clay is a ceramic, but not all ceramics are clay. Is I think kind of a good way of putting it.
Circles and squares, or squares and rectangles.
Squares and rectangles. It's all squares and rectangles. And for very modern applications, for ceramics, they're not necessarily taking clay out of the ground and then processing it. They might have their own in-lab means of processing it. But what's interesting is that clay is still considered in that circle of ceramics just because the internal structure and how it's composed is going to be very similar to even a factory-made, scientific-grade ceramic. Yeah. Which is really cool, but it's also where things start to get really, really crazy. Like you've heard of ceramic cutting knives, ceramic kitchen knives.
Yeah, incredibly sharp, right?
Really sharp. I've heard they're like some of the sharpest on the market.
Were used like very heavily in like the sushi business because they get those really nice thin slices of the fish. You want to use a super sharp knife.
Super sharp knife, yeah.
Plus, I love sushi. I love sushi.
Sushi's really good. Eat responsibly. But it's wild because I've also heard that while it is extremely sharp on one edge, if you are to kind of like put any pressure perpendicular to that, it's just going to shatter.
Super brittle.
It's very brittle, yes.
Okay.
Very brittle. So it isn't as resilient as, say, your metal knife, but for very specific applications, very, very sharp requirements where it's got to be thin or nothing, you can go ceramic and it'll work. And it'll work really, really well. I used to longboard a lot, loved it.
Oh, cool.
And I had some physical issues. That means I don't really do it as much, but I still love it. Still love to do it every once in a while, not very often. But what was really frustrating was you ride around in the rain, and very quickly after doing that, like within maybe a day even, your bearings, the actual little parts of the wheel that are metal structures that are moving around, they just rust and they seize right away, and they'll just you will stop dead. You will be riding around and you will stop dead in your tracks.
Actually sounds dangerous.
It sucks. You go flying sometimes. It's not good, which is why if you're gonna go riding in the rain, make sure to always pat down and dry your wheels off, so it's less of a risk of rusting. If you really want to be crazy about it, there are certain bearings you can take them apart, you re-oil them, which you should really do if you really want to get into it, or you can just shell out $200+ for a set of ceramic bearings.
Really?
Ceramic bearings, yes, and they are top notch. The really only downside to ceramic bearings is how prohibitively expensive they are, and how hard they are to make. But once they are made, they are unbelievably they're like really good at what they do, because they are pretty much completely waterproof. They are heat resistant up to very extremely high temperatures. So these are really crazy operating pressures that ceramic bearings can operate under. Really fascinating. I only cared about it at the time because I could run through puddles and not really give a crap and not really care. But for more industrial applications, that is huge, really huge, to the point where there was I think it was Toyota. It was a car manufacturer designed a ceramic engine.
Entirely?
And I don't know if it was entirely made out of ceramic, but I think I'm pretty much replacing all of the major metal components out of ceramic. Wow. And this thing ripped. It had unbelievably high operating pressures for the temperature that it could operate under, whereas metal components, they're going to melt after a while. Yeah. Ceramic parts didn't have that problem. But unfortunately, this engine, you're not going to see in an automobile anytime soon, folks, because, again, it's so prohibitively difficult to make right now. Our technology currently is simply not advanced enough to be able to mass produce, manufacture, or make a ceramic engine that could operate on a mass scale. It's basically just an experiment right now, but it's very exciting to think about.
I imagine the margin for errors in the sizes of those individual parts. You got to be so precise, right?
And a failure on a part that small can result in catastrophic failure for the entire system.
Explosions earlier.
Boom! Imagine that. Imagine your clay car exploding. That doesn't sound too fun. Oh man, kind of fun, but not. No, I don't know. I'd like to watch it. I wouldn't want to be in the car.
But as far as like
Mythbusters kind of thing.
I would love to see them put together an entirely ceramic car.
I'd love to see that.
Yeah, definitely not in the crash.
Oh man.
So ceramics have been like this amazing thing in the past of all of mankind and kind of defined where we've been. But as far as like where we're going, it's got a huge application in electronics, right?
And electronics as well. That's absolutely right. They're very widely used, to my knowledge, as insulators. Really great insulators for a number of electronics and electronic applications, but as well as conductors as well. Both. So yeah, not only insulators but conductors, and based off of different, of course, the chemical makeup and the setup, superconductors as well. And this is the things that material scientists and ceramic engineers have been toying around with. Yeah, we'll get into that.
That's cool.
Scientists have been toying around with to create things like supercomputers, rock stars, and ceramics are playing a huge part in that. We're talking about things like the was it the Meissner effect? I think I remember hearing. Or
is that the temperature thing?
Yes, yeah. As you, I think, fluctuate a material's temperature, most notably a decrease in its temperature, the more its properties as a conductor will increase. And so by taking these very finely tuned ceramics, super cooling them to very low temperatures, they become superconductors. Fascinating. That's where you'll see like the levitation effect with certain materials. That is due to these engineered ceramics by, as we were talking about, ceramic engineers. This is the cutting edge of ceramic science, and I guess clay science, if you really want to look at the bigger picture, where these engineers are coming up with the future today. The future today, rock stars.
Future starts now.
In terms of these supercomputers and new technologies that in some cases we're not even necessarily ready for yet. We don't even have all of the pieces in place, but we're starting to put those puzzle bits into place. Man, what a time to be alive.
So these people are creating materials based on the clay, based on sometimes even just coming from the clay we find in the ground. they're putting this work in so that with temperature they can control the amount of electricity that's flowing around in computers and using that to do stuff.
That's my understanding of it.
That's real cool.
That is some cool stuff, man. That is awesome.
Now, I know that it's also used in capacitors, right? Yes, capacitors in general. Are you familiar with what they do?
Capacitors? No.
What they do are they're a method of controlling the flow in an electrical circuit by providing resistance in measured amounts.
Huh. Oh, okay.
So if you ever see something, they're rated in ohms, I believe,
Yes,
which is the
yeah.
physical
Yeah.
measure of resistance.
I've heard of Ohm's law before. Okay. What do those have to do with ceramics or clay?
So these capacitors, specifically the ones that are used in modern computing and the kinds you could also see if you ever broke open a piece of that kind of circuit board and that kind of stuff.
I don't know what you're talking about. I've never done that.
Me neither.
Dude, you should. I highly recommend. It's a lot of fun.
Are actually based on alternating layers of metals and the very meticulously created ceramic material that is acting as a partial
Really?
insulator.
Really? Wow. And what does this do for computing?
Basically, it lets us create incredibly intricate and measured electronic circuits that we rely on for computing. You know,
Really?
computing all the ones and zeros in any aspect of computer science are based on the electrical original switches on, off, the left, right direction of electricity, whatever you want to do, how to think about it.
Okay.
And so an aspect of using that, extrapolating that into these really complicated networks of using mechanical parts of computing systems involving capacitors to create logical decisions, not an information, but an actual direction and motion of electricity. A lot of that getting really, really, really small in the size that we can fit in our hands and cell phones is thanks to ceramics.
Thanks to ceramics. So what did technology look like before this advent of ceramic capacitors?
Well, I think you were the one actually explaining what was the law to me. Moore's law?
Moore's law? Yeah.
Is that the one where, you know, the technology gets twice as fast or twice as small?
Oh, that is Moore's
something
law.
like that.
Yes.
I wasn't sure of the actual
Yeah.
time frame.
Yeah.
But it used to be huge. We used to, I'm not actually sure what was used before ceramics
Yeah.
and capacitors and that
Okay.
kind of stuff, but I know it took up significantly more space, and this is in the era of like vacuum tubes being behind every
Vacuum
CRT
tubes.
monitor
Oh
and everything
man.
being like huge.
Like punch cards, I think, for these kinds of things.
And granted, this is definitely outside of my field. I definitely am more of a software guy than a hardware guy.
But it's still just really
fun to
great
think about.
think about and just appreciate that the technology that landed Apollo 11 on the moon is less complicated than what you have in the smartphone you likely have in your own pocket, thanks to these ceramics. Cheers. That is wild.
It's a bit of a jump, but it does make sense to me at least. Because everything is a
Absolutely.
stepping stone to what we have next, you know?
My goodness.
We've seen clay and ceramics be used for jugs taking water in the dawn of humanity, and parts of computers that are so small I can't think about them in the computers and AI of the future, but like they're also used as straight up building materials, right?
Have been for generations and generations, just almost as long as we've been using them for tools. We've been making our homes with clay. And actually the number one use of clay around the world is in making bricks. Brick making.
That's number one.
That's number one.
I did not expect
That's
that.
number one use. That's totally wild. I didn't expect that either. But yes, people, need bricks, Out here in California, it's less common to see brick buildings.
We can really do it because of earthquakes.
It's not really used as often, but almost everywhere else, like in many places around the world, clay is the number one go-to. And I'm like, why wouldn't you? Heat resistant, insulating. It's got everything you want in a good wall to your home.
Plus, I love the aesthetic of that red brick,
Aesthetic of that red brick, and that wise little pig didn't make his home out of brick for nothing. He knew what he was doing, Heck yeah.
If it ain't broke, don't fix it.
Ain't broke, don't fix it.
But when we talk about clay, we talk about building materials in general. Being raised around here, my mind immediately goes to like old Adobe clay, homesteads, that kind of stuff. Is that the same kind of clay?
It's actually not, and it's not clay at all. Adobe
Really?
is an entirely different building material. It is more of just a generic mud. It's going to have silt in there, it's going to have sand in there, it's going to have clay in there as well, all kind of mixed together. And it's also going to have some organic ingredients in the form of like hay hay is going to be commonly used as a reinforcement in the adobe. It helps to provide some rigidity.
Kind of like organic rebar.
Organic rebar, I like it. Yes, yes, indeed.
Oh,
man,
that's good. So it's basically just like maybe a higher content of the particle size stuff that's kind of clay size that gives it that quality that makes it stick to my shoes walking through those fields.
That clay content is absolutely what that's going to be. That kind of glompier, stickier kind of stuff. That's what makes a really good mud is going to be that clay content there. Absolutely.
Good mud.
That's the best mud. The kind of mud that gets you good and stuck. The kind of mud that takes your shoes off. That's clay.
The kind of mud you could build a house out of if you needed to.
Like the kind of mud you could build a house out of. And how cool is that? My goodness, man. Like, what a time to be alive. Tell you what.
Past, present, and future.
Past, present, and future. Oh, man.
Ugh.
Clay's there, and it's coming. It's coming for you, rock stars. We are flying our Adobe homes to the moon on ceramic engines. Let me tell you what. And
To 3D print more clay ceramic engines.
To 3D print more ceramic engines, man. All orchestrated by a supercomputer running on ceramic superconductors. Who knows? The future's wild.
That sounds great.
Something tells me Clay's probably going to be there in one form or another.
Probably till the very end.
Probably till there might be clay that does us in. You know? Everything just dissolves and turns to clay in the end. It's just the natural state of things. I mean, since clay particles can literally be just a couple atoms in size, eventually it's all just going to deteriorate and turn to clay. So eventually we all shall turn to clay, rock stars. The eventual heat death of the universe.
That got deep.
And that's what we do here on the Rocks.
That's why we drink.
We're digging deep. We're asking the deep questions here, the hard questions. Hard rocks and harder questions, so you don't have to, rock stars. That's right. This has been a awesome episode of On the Rocks.
It's been our first episode of On the Rocks.
Yes, indeed. To the first episode, rock stars.
The first episode.
Anthony, Michael, this has been absolutely fantastic. Thank you so much for your questions.
Michael, Anthony, thank you so much for educating me about something I was super curious about, and you were the best person to come to with these questions.
Well, thank you so much. I really appreciate that. Until next time, rock stars, enjoy. Get out there and start digging deep, rock stars. Ask those deep questions. Get down to the bottom of things, to the bedrock, if you will. And bring them to me. Feel free to post your own questions in the comments. If you have anything you'd like to know about clay or otherwise, or any suggestions or recommendations if you'd like to see future episodes of On the Rocks, let us know. I'd love to see it. We'd love to hear it. So
got a lot more whiskey to drink.
Absolutely. Until then, keep on rockin', rock stars, and we'll see you next time. Cheers.
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 You might be interested in this. You know, when you're tasting alcohol, there's a term for tasting the flavor of the dirt that an alcohol is produced in.
Oh, really?
Yeah, they call that the terroir. Terroir?
Terroir?
Something like
I'll put that up. That's fascinating. I did not know that.